Okay, so we have our next question here, which was the shape of a cycle track is modelled by this curve. And we have to show that for the first part. So hopefully you picked up on the fact that this would be some implicit differentiation. So I've made a start and I've done the first line of working out already. So x squared, we would just differentiate as normal. The blue part here is we're doing the product rule. So a shortcut is we can keep and differentiate to get our first result, and then we add to it the piece when we differentiate and then when we keep this part the same. So notice any time that we differentiate a y part, we add a dy dx. Same over here, 5y squared. Well, if it was 5x squared, we would say 10x. So because it's y, we do the same as before, and then we correct with this dy dx. The 0 there to account for 60 differentiating. So we're going to finish off this question. So the first thing we're going to do is we are going to keep all the dy dx terms on one side. So I'm going to keep my 4x dy dx plus 10y dy dx and move the other terms to the other side, which means I will have a minus 2x and a minus 4y. Okay, we will factorize the dy dx, leaving 4x plus 10y. Okay, and then we will divide by that bracket. So we're going to say dy dx equals minus 2x minus 4y over 4x plus 10y. Some other things we can do, because every single number in the fraction has the same factor of a 2, we can divide every single term in the fraction by that 2, which would give me the following result. Now I'm just going to check it against the show that, and there is one other small change I could make, which is I can factorize out a minus from the numerator, and that would leave me with this part here, and 2x plus 5y. The dy dx is already there, but just to sort of put the cherry on top, we will do that as it is a show that question. Okay, so that's the first part. So next, we have the point that is furthest west. Find the exact coordinates. So this is quite an interesting question. We're quite used to having a fraction, and then maybe when we find a maximum, for example, we understand that dy dx is 0, and that means that we have to set the numerator equal to 0. But here, we've got a vertical line. So at this point, the idea is that the denominator is what we need to set equal to 0. Okay, the logic is along the lines of at this point the y value might be changing at that instant, but the x value is not, because the x value is sort of, turning back. Okay, so we are going to set 2x plus 5y equal to 0. Okay, so if you have vertical lines with dy dx, this is a step that you might be expected to sort of work out. And if we do some extra work with this, we can say that y, if you've got the y on its own, you would say y is equal to minus 2/5 x. Now, that doesn't seem that useful until perhaps we kind of try graphing it. So if I imagine going through the origin a line of y equals minus 2/5 x, it would look something like that. So what I think I need to do is I need to find out where those lines are crossing each other. Because at that point, it's following the rule that the y value is minus 2/5 of the x value, and it's on this curve, so it must follow the rule of the original curve. So we're going to solve those two equal to each other. So the original is x squared plus 4xy plus 5y squared equals 60. So we're going to sub in this result here. Okay, so plus 4 lots of x minus 2/5 x plus 5 minus 2/5 x squared equals 60. And if we do that, we end up with lots of fractions that have a fifth in them. So you get minus 8/5 x squared. Over here you get 4 over 25. So you get, for this one, you get plus 4 over 5 x squared, 60. And this is the same as 5x squared over 5. So this actually all turns into x squared over 5 equals 60. So x squared is 300. And then when we solve that, we need to realise that we're interested in the negative part, aren't we? Because it said furthest west. So x will be equal to minus 10 root 3. And subbing back in probably to this one over here, you're going to get that the y value is 4 root 3. So there we go. Let's make sure the minus is clear. Minus 10 root 3, 4 root 3, because we set the denominator equal to 0 rather than the numerator equal to 0, which is what we do the vast majority of the time. So explain briefly how you would find furthest north. So furthest north would be the same sort of idea. We would solve x plus 2y equals 0 with the original curve, x squared plus 4xy plus 5y squared equals 60. And we would also just make sure that we use the positive y value. So using only the positive y value. So yeah, interesting question, that one there.